Great day everyone. This video is a content one. We are going to see trigonometry today. Trigonometry is divided into two divisions in IGCSE. The two divisions are right triangles and non-right triangles. In this video, we are going to see right triangles. Let's get into the video. Right triangles have two subdivisions in it. The first one is Pythagoras theorem and the second one is trigonometric ratios. Let's start with the Pythagoras theorem here. So what is Pythagoras theorem is, I will write what is Pythagoras theorem, then I will explain it in the diagram. Pythagoras theorem can be said in words: a square plus b square equals h square. Then this a square and b square, by relating with the trigonometric ratios, I can write this as opposite side square plus adjacent side square, that is equals to hypotenuse square. So what is this opposite, adjacent and hypotenuse, or else what is a and b, at last what is h? Let's see here in the right angle triangle. You can see that right angle triangle here, it is ABC, right angle at B. In this right angle triangle, the side which is opposite to the right angle is called hypotenuse. And hypotenuse is the longest side of the right angle triangle, because in this right angle triangles we will be having two acute angles and one right angle. We know that in a polygon, longest side is always opposite to the largest angle. Here angle A and angle C are acute angle and angle B is right angle, so that angle B is the largest one. Since B is largest, hypotenuse is going to be the longest side of the right angle triangle. Then in any problem, they will be particularing any one of the acute angle. For example, we can take here the particular, or else the mentioned angle in the problem is angle A. So that the side which is opposite to the acute angle mentioned is going to give us a new side, and we are going to name it as opposite side. The side which is neither hypotenuse and nor opposite will be called as adjacent side. In this problem, the side which is opposite to the angle C, or else the side which is not hypotenuse or opposite, that is AB, will be called as adjacent side. Here, if you add the square of adjacent and opposite, it will give the square of hypotenuse. That's what I have mentioned here: opposite side square plus adjacent side square. The O means opposite side, A means adjacent, and H is equal to hypotenuse. In other words, what it can be said, suppose if you are not going to name this as opposite and adjacent for your lower grades, you might have learned it as A and B. That is a just normal naming, that any one side can be taken as A and in another side can be taken as B. And this is only for the Pythagoras theorem. But when you are going to learn both the trigonometric ratios and Pythagoras theorem, better we can consider that one side as opposite side and another one side as adjacent side. Opposite side is nothing but the side which is opposite to the mentioned acute angle. Then the side which is neither hypotenuse nor opposite is going to be adjacent side. It is very easy to find out that unknown value in these equations. Let's do one question. For example, if we are taking the first one, 3 square plus 2 square equals to h square. So here we have to find out that h value. So h square is equals to 3 square, that is 9, plus 2 square is 4. H square equals 9 plus 4, we are getting 13, and H is plus or minus root 13, what we will be writing it normally. But here we should not do it, because suppose if you are taking the case minus root 3, the side hypotenuse will be that length of minus root 13, and it is practically not possible. So the lengths are always going to be the positive, and you can mention H is root 13. So h is of length root 13. In the similar way, we can find out that adjacent side square here and opposite side square here. So in general, if we have to say, hypotenuse, opposite side and adjacent side are the three values have got involved in the Pythagoras theorem, and any two values will be given, we will be able to find out the third side. It is a condition. In this condition, we can find one of the unknown value. It can be anything, then other two value must be known value. Next, we will be proceed with trigonometric ratios. Which is trigonometric ratios? Trigonometric ratios, we have mainly three. They are sine theta, cos theta, tan theta. Maybe you will be feeling that what is theta is, it's very new to you. Theta is in a Greek alphabet, and here we are using it for the angle, acute angle, which we have mentioned it. And it is only for acute angle, not for the right angle. So what is the formula for sine theta? Actually, sine theta is opposite side by hypotenuse. Cos theta is adjacent side by hypotenuse. Tan theta is opposite side by adjacent side. Tan theta is a special one here, that tan theta can be also written as sine theta divided by cos theta. Always keep it in your mind, this S, C, T should be a small letter. You should not write in the capital letter. Now, let us see how are we going to find out the sine theta value, cos theta value and tan theta value. We can take this first example because in the first one only we have taken all the values. We know all the values of that sides, so that we will proceed with that. Here opposite side is having the length of 3 and adjacent side is having the length of 2. Then hypotenuse is having the length of root 13. Suppose if you are finding sine theta, so sine theta value is opposite side, it is 3 divided by hypotenuse, it is root 13. Adjacent side by hypotenuse is for cos theta, so that it's going to be 2 divided by root 13. Maybe you can divide sine theta and cos theta value for tan theta because I have mentioned here, or else you can even use that opposite by adjacent. Opposite is 3 here, divided by adjacent is 2. That is what the tan theta value. But if you are asking me whether the Cambridge board is going to ask find the sine theta, cos theta, tan theta value, mostly not. So how the questions are going to be? The questions are going to be in the form of find the acute angle. So two sides will be given. So it can be any two sides. Let us consider a question. They are asking the value of angle A, that is theta, and the two given values are side 3, which is opposite side, and then side root 13, its hypotenuse. If it is so, what we have to do first? First we have to identify that the 3 is opposite side and then hypotenuse is root 13. Then the two given sides are opposite and hypotenuse. We have to select the ratio, which trigonometric ratio we are going to use it. We have sine theta here, cos theta here and tan theta. Which ratio is relating opposite and hypotenuse? We know that opposite and hypotenuse is sine theta. So first what you have to write here is sine theta equals. So the two given values you have to write opposite side in the numerator divided by hypotenuse in the denominator. Then what you have to do, since you have to find out the theta and keep that in your mind, sine is an operation like multiplication, division, addition, subtraction, square root. So sine is one of the operation and it is applicable only for the angles. So sine operation goes right side, it will become sine inverse. So sine inverse of 3 divided by root 13 is what we will be getting. Now, if you put these values in the calculator, you will be getting the value of theta perfectly. We are getting the calculator answer as 56.3 for three significant figure, and one more answer also we are getting here, that is 124 degree. But in your calculator you might see that you'll be getting only 56.3. Then how are we going to find out this 124? Do we have any specific method for this? Yes, we have. And how are we going to calculate for the different ratios? Let's see it now. Normally, if you are using these kind of equations like sine theta equals the given sides or cos theta, tan theta, then you'll be writing theta equals to sine will go that side sine inverse, cos will go that side cos inverse, tan will go that side tan inverse. Simply you will be using your calculator and you will be getting the value of theta, and only the first value you will be getting in the calculator. How to get that second value? Actually, the theta gives two values in 0 to 360 degree. So in between 0 to 360 degree, we will be getting two angles value for these calculations, but calculator will show always one. How are we going to get that other value? Let us consider the Cartesian plane. Cartesian plane has four quadrants in it: first quadrant, second quadrant, third, and fourth. All the three trigonometric ratios sine, cos, and tan are positive in the first quadrant. So I'm denoting it with all. And in the second quadrant, only sine is positive and the rest of them are negative here. And in the third quadrant, only tan is positive and rest of them, which means sine and cos, will be negative. And in the fourth quadrant, only cos is positive, then sine and tan are negative here. So that if you are going to calculate the values, angle value, calculator gives always this all, which means the first quadrant value only it gives. It won't give the second quadrant, third quadrant, or fourth quadrant. It will give only that positive value we have to consider as an answer. But still, how to get that other value? We know that if that ratio what we are using is sine, sine is positive in the first quadrant, that we directly got in the calculator here. And how to get that another one? Actually, the second quadrant value. How to get the second quadrant? For sine, what is the answer you have got here? For example, we can consider that value as x. Then sine is positive in the second quadrant, so that another value, how you have to get now? It is 180 minus the value which you got here, that is x. And tan is positive only in the third quadrant, so that if you have to find out the second angle value of the tan, then the value what you have got in the calculator, that first quadrant value, should be added with 180. Since it is in the third quadrant, we know that third quadrant is 180 plus, so that if you add 180 with the calculator value, the first quadrant value, you will be getting the tan second value. Then for cos, we know that it is, you can think that we will be adding the 270, but we are not going to do that. We are going to subtract this in terms of x, so that we are going to subtract it from 360. So 360 minus will give the second value of the cos. I'm repeating, the first quadrant value of all the three coordinates, all the three trigonometric ratios will be getting in the calculator, which means the first value will be getting here. For the second value, if it is sine is the ratio which we have used, then 180 minus x you have to do to get that second angle. If it's tan, then you have to do 180 plus what is the calculator value. So if it is a trigonometric ratio is tan, then you should use 180 plus to get the second. Then to get the second value, if the used trigonometric ratio is cos, then you have to use 360 minus calculator value, so that you will be getting the second angle for the cos. So that's it. If we have to see why the sine is positive in the second and tan is positive in the third, cos is positive in the fourth one, we will be seeing it in the separate video. So that's it, the concept we have for trigonometric ratios in terms of right triangles. We will be seeing a past paper question and you will be getting more idea. Let's start solving the past paper questions. So this is the question we are going to solve it now. You can see that it's a right angle triangle, so either we are going to use Pythagoras theorem or else trigonometric ratios. All the three values, two inputs and then one output. How am I saying that this is output? Because this is unknown, so two known and then one unknown, everything says that it's a side, so that we are going to use the Pythagoras theorem. Initially I can write what is Pythagoras theorem is. I can say that opposite side square plus adjacent side square equals hypotenuse square. Here they did not mention which side is opposite and adjacent, because there is no angle mentioned. So we can even take that a square plus b square equal to h square. Maybe to practice with opposite and adjacent I have taken this. Any one side can be considered as O, another will be considered as A. We can clearly see that here hypotenuse is 8. So if you are substituting the values here, we are getting O is x square. Just consider, plus adjacent we can think that as 5 square, that is equal to 8 square is what we are getting. If you are going to solve this, then we want to find out that x square, so let it be in that one side and move all the known values to that another side, and that is what we will do it for algebra. It's going to be 8 square minus 5 square. Then after that we want to find out that x, as it's told before, it's going to be only positive square root, so it's positive square root of 8 square minus 5 square. Why did not I find the value? Because I'm going to use the calculator value. Since I'm going to use the only calculator value, I no need to do this 8 square values and then 5 square values. Simply I can put these all the values in the calculator and then I will get the answer. I'm getting now, it's actually root 39. I'm getting root 39 is nothing but 6.24. I can write that in three significant figure. So x value we are getting 6.24. This is the we are going to solve next. So in this question we have to calculate the value of x and two sides are given, one angle is they are asking, so that we can say clearly here we are going to use trigonometric ratios because only sides are getting involved in the problem. That's a Pythagoras theorem, side and angle, that is trigonometric ratios. Okay, now we will see that what sides are given, so then only we can select which ratio we are going to use it. We have this angle x here and its opposite side is going to be opposite, and the side which is opposite to the right angle is hypotenuse, and this third side is going to be adjacent. Two values are given, one is 2 and then 5, and we are realizing that 2 centimeters adjacent and then 5 centimeters hypotenuse, so that adjacent and hypotenuse are related here. We know the ratio what we have to use is cos. So cos in the place of theta I have to use here x, because in the problem they gave that angle as x. Cos x equals to adjacent, or you can write in general first cos theta. So first let us write that straight formula, cos theta equals adjacent by hypotenuse. Since we have realized that we have to use this ratio, then we can start substituting. Cos theta values here x, that is equal to adjacent is 2 divided by hypotenuse is 5. And as I said before, we have to calculate the value of x, so that cos will go that side, it's going to be cos inverse. So cos inverse of 2 by 5 is what I have to put in my calculator. When I'm working 2 divided by 5, and if I'm taking the cos inverse for that, I'm getting the answer as 66.4. That is what the value I'm getting in the calculator. And I told you that we have to find out that one more value also. For that we have to subtract that answer from 360, and what we will be getting here is, it is 293, or we can say even 294. But clearly in that right angle triangle, two angles are going to be acute angle, so there is no possibility for 294. Maybe we will use this for some other problems where it's required. As of now, this angle is only a acute angle, so that we can take that answer x as 66.4. When we are seeing the next question, we are realizing that again we have to use the trigonometric ratios. Why it's trigonometric ratios? Yes, because here they have given two sides and then one angle. If it is so, then we have to use the trigonometric ratios. It's not like a previous problem, because in the previous one they have asked the angle, but here they have given the value of angle, but they are asking the side. Let's find what side we have to use. So 53.2 is given and its opposite side, that side which is opposite to the angle, that is x. So its opposite side, and another one given side is hypotenuse. So two sides opposite and hypotenuse are getting involved. We know that what ratio we have to use. The ratio which is connecting opposite and hypotenuse is sine theta. So sine theta equals opposite divided by hypotenuse. If I'm going to apply the given values, I will be able to find out the x value easily. So sine, that angle I should write it as 53.2, that is equal to opposite side, that's unknown, so let me take that as the given x variable itself. Then hypotenuse is 29. When I want to find out the x, that basic algebra strategy says that keep that known one side and then unknown in the another side. So x equal to 29 will come here, it will become 29 into sine 53.2. If I put this in my calculator, then I will be getting the answer, that is 23.22. So x value I'm getting 23.12, but I have to write three significant figure answers, so it's going to be 23.2. So that's what that answer I have to write here. So answer x is 23.2. Next, let's start solving this problem. The diagram shows a pyramid with a horizontal rectangular base. So the base is a rectangle. The rectangular base has length of 4.8 meter and width 3 meter. And the length height of the pyramid is 4 meter, that is mentioned here. Calculate y, the length of sloping edge of the pyramid. So we have to find out this value. So let's see where it is connected. So if this is the hypotenuse, we can see this right angle to triangle. So 4 and its another one side is actually we don't know, but we know that this is hypotenuse of half of the hypotenuse of this right angle triangle. You might see that this is not a right angle triangle, but they have mentioned it's a rectangular base. So for our look for the 3D shape, they have given like that, but it is a right angle triangle. So first let's calculate this value. Maybe we can name that as x. So x is the hypotenuse. So here we are going to use only the Pythagoras theorem because everything is sides, so no other angles are involved. So let's start writing x square, because that's a hypotenuse square, that is equals to 4.8 square plus 3 square is what we'll be getting it. So x square we are getting as 32.04. After getting that x square, actually we want to calculate what is this half of the value, or we want to calculate what is the exact hypotenuse is. It is x equal to square root of 32.04. I'm not calculating that exact answer of this because I'm going to use it for further steps so that I can keep that as exact value instead of a decimal value. So this is what x answer. Let me start substituting in the required one. Actually here y is also a hypotenuse. So y square equals, here it is 4 square and half of x square, or I can even say that it is x by 2 the whole square. I have to take it. So what I will get is 4 square is 4 square and x by 2 whole square is root of 32.04, and that I have to divide by 2, then I have to take a square, and the same value I can put in my calculator also. So that I will be getting the answer for y square as 2401 divided by 100. And I want to find out the value of y, so that I have to take the square root for this. That is nothing but 2401 divided by 100. And if I'm doing this step, this arithmetic calculation, then I'm getting the answer for y as 49 by 10, or else I can write that as 4.9. So first, how did I do this? I have to find out y, and that is related with this green triangle. In the green right angle triangle, one side is given and another base is not given. So first I have to check whether I can get this value or not. Then only that by using Pythagoras theorem it is possible. But I can find the whole diagonal by using Pythagoras theorem for the base rectangle. So it's a 4.8 square plus 3 square gives this x square. So by using this Pythagoras theorem, I'm getting x square value. Then I'm calculating what is x, and I'm keeping that as 32.04 square root itself because I want that exact value. I got almost this value, but I know that I have to use only x by 2 here. If I'm going to use only x by 2, then I can write how that Pythagoras theorem is relating for this right angle triangle. So y is the hypotenuse, y square equals, so base square, that is 4 square, plus half of that is x by 2 the whole square. X by 2 whole square value, x by 2 value I have calculated here, it's square root of 32.04 by 2. If I take square for this and I can put all these things in my calculator, then I'm getting this simplified answer as 2401 divided by 100 as the y square. But I have to calculate y, so if I'm taking square root of this, then I'm getting the answer for y is 4.9 centimeter. And that's it. Let's continue. This problem has one more subdivision, that is, we have to find out the angle between a slope edge and the rectangular base of the pyramid. So whenever you are going to find out the angle between a slope edge and then rectangular base, so if any base are given, then you have to consider the whole diagonal. That base diagonal is what you have to take for calculation. But here we cannot take the whole diagonal, because when we are going to relate this right angle to triangle, we can consider only this triangle, we can consider that. And in the previous problem we have got that answer for x as 32.04 divided by 2, and y value finally we have calculated that as 4.9. So by using that only we are going to calculate this angle. Actually, which angle they are asking? This is what the angle they are asking. Angle between the sloping edge. Actually, this is the sloping edge between sloping edge and then base. Now we have to consider the diagonal of the base. So this angle is what we have to calculate. So how are we going to calculate? It is related with trigonometric ratio and 4.9 root of 32.04 by 2. So all the three sides are there, so we can use any ratios. But when we are considering that these two sides are a bit easy, so this 4 and this 4.9 are a bit easy, opposite side and hypotenuse are those sides, so that I can use sine theta here. I know that sine theta is opposite by hypotenuse. Here sine, I can keep that as theta itself because they did not mention any angle variable here, so that I can use the same. But equals opposite is 4 by hypotenuse is 4.9. If you are asking how did I take that 4 as opposite, because this is what that angle that I have to calculate, so that side which is opposite to them is 4 and the side which is opposite to the right angle is 4.9, so that sine theta equals to 4 divided by 4.9. At last I will get the value of theta. So how to do it? It's sine inverse of sine, will go that side, it's sine inverse of 4 divided by 4.9. So this is what the calculation actually I have to do. 4 I have to divide by 4.9, then I have to apply for this sine inverse in my calculator. If I do this, I'm getting the answer as theta as 54.71, and for three significant figure I can write that theta value as 54.7. I will recall that one more concept, that for if it is a sine ratio, then how I have to find out that another value. Actually, for that another value I have to subtract this theta value from 180. So 180 minus theta is, I'm getting that answer as 125. And even here I should not use this value. Why I should not use this value? Because this angle is actually going to be a right angle to triangle. If this triangle is a right angle to triangle, angle must be acute angle. Then you can question me, even in the previous question we did not use the concept, and even here we did not use it. Then where are we going to use it? Wherever you are going to use it in non-right angle triangles, in any other places, if you are going to apply this trigonometric ratio, or else this sine function or cos function or tan function, if you're going to use it, then you will be finding both the values. But here why that second value is not applicable? Because we know that clearly it is acute angle. One angle is a right angle, other two angles are going to be acute, so only that direct calculator value or else that acute angle among them is going to satisfy. So it is 54.7. That's it. We will meet in the trigonometry part 2, which is non-right angle to triangle. Until then, bye from Satish. Bye.